NetFlow is an information visualization tool that allows you to analyze how a network evolves over time. NetFlow presents similar data found in many other network visualization tools, only we now have the ability to view these same traits as they vary over time. NetFlow is broken into four main components: the preview window, the workspace window, the control panel window, and two temporal-based windows. The starting point is the preview window. By default, the workspace window is loaded with degree. Here in preview, we can see a preview of each metric we have available. The idea is to find something interesting to a user and then work with that in the workspace window. Here we have three matrices: degree and two word count matrices. The word count matrix is a matrix that shows how often an author used the above words and their combined abstracts. In this example, count of visualization shows how many times an author used visualization in their paper. This seems interesting, so I'll check that. Doing so updates the workspace window. The workspace window is where we gain a view of the network over the entire temporal dimension. The layout is a heat map, with black indicating that a particular node has no value for that particular metric in question at that time period. Here we see how many times an author used the term visualization. The workspace window plots the nodes along the x-axis and time along the y-axis. In this data set, the x-axis are authors and the y-axis is binned by year. The gradient is from white to red, with white being the minimum and red being the highest value. Black indicates, again, nothing, and the legend is present in the control panel. Zooming in allows the user to closely examine the data. Tooltips are set up to show absolute values for particular cells. Clicking a highlighted user highlights the row to ensure all cells are accurately identified for that author. Let's switch back to the degree matrix and explore the control panel. The control panel to the right has a variety of options. We can cluster nodes. Clustering will identify nodes that are similar and place them next to each other. Upon clustering, if we wanted to, we could aggregate nodes to further summarize the network, but we'll skip that for now as we turn to aligning the heat map based on relative time events. If we choose to align based on when nodes join the network, we get an adjusted heat map that shows in the first column what an author did the first time they were here, and all subsequent columns are relative to their second, third, and subsequent actions. The time column here is OBE, as time is relative for each node. We've discussed zoom earlier. We've also incorporated filtering, time binning, and help sections, but we'll skip over those for now. Before we go to the temporal window, let's place the matrix back in its original form. The two temporal windows below do one of two things: a list of detailed metrics, as well as an adjacency matrix, exists for each of the green and blue columns present in the workspace window. The list shows the node name, time period, degree, word count matrix, and beginning of the abstract. Clicking on different columns updates the time for that window below. A benefit of the NetBeans platform is we can pull windows out of the main GUI and expand. Doing so allows us to better see the adjacency matrix. The node-to-node comparison is an adjacency matrix for that time period. The pull-down allows the user to select what metrics they want to explore for that time period. We have degree, word count, Pearson coefficient, cosine similarity. For degree, cosine, similarity, and word count, the same gradient is present as in the matrix in the workspace window. Here, word count is how often a pair or group of authors use the term on papers they co-authored. White signifies there is no edge between the two nodes, and thus they did not use those terms. The color scale and piercing coefficient helps indicate which pair of nodes are alike and which ones are different throughout the network. Black again indicates no edge between the nodes. The piercing coefficient in this implementation is normalized from -1 to 1, with yellow shading indicate values that are less than 0, and orange and red for values greater than 0. Thank you for visiting NetFlow.